Hey guys, and welcome to Terrand.
I'm Emma Albright.
And I'm Victoria Kondo.
And this is our project.
So, what is Terrand? Terrand is a procedural terrain generator based on Perlin noise. As of now, we're using Unity's built-in Perlin noise function, but we plan to implement a version of it ourselves. When we generate terrain, it never ends. With our high-end Unity editor, you can create your own regions and mountains. You'll always be able to come back to your favorite maps because of our seed-based generation. So, what have we accomplished so far? Well, our terrains are seamless. Using global amplitudes, we are able to seamlessly transition between chunks. To keep it performant, we've implemented threading with synchronization to calculate chunks concurrently. Using height curves, we can ensure that our water is not bumpy. We've also implemented octaves, persistence, and lacunarity into our noise function, which all provide different functionalities for the look of the map.
Right now, everything is vertex-based. We aim to voxelize our terrain. Currently, our noise value is clamped between 0 and 1. We'll multiply the decimal by 100 to get the number of voxels and height. We have yet to implement shaders, but we aim to have a cartoony shader in the style of content warning as seen in the slides. We hope to implement trees and biomes with more noise maps, perhaps with different functions other than Perlin. And here's our demo. So we start with showing you a noise map and how noise scale, octaves, persistence, and lacunarity affect the map. We then show the seeds, which are all individual and will make the same output every time. And then the offset X and Y. X is to move it left and right, and Y is to move it up and down for some more precision whenever you're making the maps. Then we go to the color map. You can change the color based off of max height, so everything from 0 to 0.3 was just changed to yellow. I'm also going to show how you can change the white caps by changing the gray to move it up a little bit. Then we go to our mesh, which means we have to get rid of the plane that showed our different textures and go to our mesh, which will show the actual heights. It takes a little bit, but we end up showing with our texture, and here you can see the heights. And here I'm messing with the mesh height curve, which is basically making sure our water isn't bumpy. By doing this, everything from 0.4 and down to 0 will be flat. And here I'm changing the height multiplier so that our mountains can change in height and dynamics. Now I'm going to go into game mode. Right now we're using a chunk loading system which has different level of details based off of how far the chunk is away from the viewer. So chunks that are further away have less detail, which makes it more performant. Also, as you'll see whenever I go high up in the air, you'll see chunks loading in, and I will eventually also go backwards and you will see chunks loading out. Theoretically, we also can change the scale of the map. So let's say you make a player object that is a certain size. You can scale up the map so that it doesn't look like you are as tall as the mountains.
And this is the GOAT, Sebastian Lake. He made an amazing tutorial on terrain generation in Unity. A lot of the project was based on the tutorial, and a lot of the topics in his tutorial inspired our plans going forward.
Thank you!
Perfect.